This video will be covering numbers 82 through 84 on the multiple choice 2 and question number 4 on the 2016 Calculus AB FRQ. Question 82 asks you to evaluate the integral of f of 2x from 1 to 3. This is a very simple question because all you have to know how to do is use substitution. You set u equal to the inner function, which is 2x, and you take the derivative, giving you du equals 2 dx. You simplify this further to get 1/2 times du equals dx, and now you're ready to use this information in the integral. You replace f of 2x with f of u and the dx with 1/2 times du. Because 1/2 is a constant, you can pull it out to the front, and now you're ready to use part 2 of the fundamental theorem of calculus. FDC states that the integral of f of x from a to b is equal to f of b minus f of a, where the capital letter F stands for the original function. So you replace f of u with the original function f of 2x, and you plug in the b and a values and use FTC, giving you 1/2 times f of 2 times 3 minus f of 2 times 1. This simplifies to 1/2 times f of 6 minus f of 2, and if you distribute out the 1/2, you get 1/2 times f of 6 minus 1/2 times f of 2. So E is your correct answer. Question 83 asks you to find the limit as x approaches a of x squared minus a squared over x to the 4th minus a to the 4th. Just by glancing at this problem, you can see that if you plug in a for x, you would get 0 over 0, which is an indeterminate answer. So to get around this, you would have to use factoring. Notice that the numerator is a difference of squares, meaning that it can be simplified down to x minus a times x plus a, and the denominator is the same thing. X to the 4th minus a to the 4th is equal to x squared squared minus a squared squared, so that simplifies down to x squared minus a squared times x squared plus a squared. But notice that this is also a difference of squares, so you can simplify that further to x minus a times x plus a. And now you can cancel out the factors that do cancel out, and then that leaves you with the limit as x approaches a of 1 over x squared plus a squared. This simplifies to 1 over a squared plus a squared, which equals 1 over 2a squared. So the correct answer is B. Question 84 asks for the value of k if the population doubles every 10 years. This question is really easy if you know just one formula, which is y equals ce to the kt. This formula is used for almost every single exponential growth and decay question, so if a question ever mentions population growth, radioactive decay, or the half-life of an element, you know that this is the formula you're going to use. In this formula, the c stands for initial value, the k is a constant, and the t stands for time. In this question, given that the population doubles every 10 years, if the starting population amount is 1, then you know that in 10 years, the population is going to double, giving you 2. And since this happens every 10 years, you plug in 10 for t. Now all you have to do is solve for k. You take the natural log of both sides to get rid of the e, and you're left with ln2 equals 10k. Then you divide both sides by 10, giving you k equals ln2 over 10, and if you plug this into the calculator, you get approximately 0.0693. So the correct answer is A.
Alright, so today I'll be showing how to do the 2016 Calculus AB FRQ number 4. So here's just a little overview of the question. We're given the differentiable equation dy over dx equals y squared over x minus 1. And we see that this problem has 3 parts. Part A, you're asked to find a slope field. Part B, you're supposed to find the equation of a tangent line at a certain point and then use that equation to approximate at a different point. And then part C, you just have to find the particular solution. So for part A, we see that we're given these 6 points, and referring back to the last slide, we're given the slope equation, which is just dy over dx equals y squared over x minus 1. And so if we take these 6 points, we can plug those numbers into the dy over dx to get the slopes at those points. And once we plug them all in, we can get the slopes and plot it on a graph like this, and it should look something like that. Now for part B, we're asked to find the equation of a tangent line at x equals 2, and then use that equation to approximate at x equals 2.1. So here we're given the condition that at f of 2 equals 3, so that we know that there's a point at 2, 3. So we can find the slope at that point using the dy over dx differentiable equation again. And we get 9. So the slope at that point is 9. And we also, so now we have the point and a slope, so we can use point slope form. We get y minus 3 equals 9 times x minus 2, and if you simplify that down, you get y equals 9 times x minus 2 plus 3. So now to approximate at the point 2.1, you get f of 1, or f of 2.1 is about, if you plug it in for x, you get 9 times 2.1 minus 2 plus 3, which is just 3.9. So for part C, we're asked to find the particular solution y equals f of x to the given differentiable equation. And again, we're giving this initial condition that f of 2 equals 3. So if we look back to the differentiable equation again, we see that it is dy over dx equals y squared over x minus 1. So the first step is you want to divide by y squared and multiply by dx so that you get the y's with the dy's and the x's with the dx's. So then now you can take the integral of both parts, and once you do that, you get negative 1 over y equals natural log of absolute value x minus 1 plus c. And so the next step is you want to solve for this c right here, and we're given the initial condition that f of 2 equals 3. So we can plug in x for 2 and 3 for y, so we get negative 1/3 equals natural log of 2 minus 1 plus c, and if we solve for c there, we get negative 1/3. And so now we can plug this c back into this equation here. We get negative 1 over y equals natural log of absolute value x minus 1 minus 1/3. And if we just solve for y, we get y equals 1 over 1/3 minus natural log of x minus 1. So that is how to do the 2016 Calculus AB FRQ number 4. Thanks for watching.